the hard part about this to believe about this video is that this is going to be the last video for the year, and I just can't believe that we're already towards the end of the year, despite everything that we've faced and the challenges through this remote learning. I still think time's gone by pretty quickly, but I did want to make a quick video just so you have some support on your exit assessment and can refer to these strategies at a later time if you need to, like when you take the SAT in the fall. Now, the next strategy is going to be using key coordinate geometry concepts. We want to deal with this or use it whenever we're dealing with lines or polynomials on the XY plane. And we did do an example a few weeks back with finding the line that's perpendicular. Remember, it's the negative reciprocal. So if we have this negative 3x, we put this 3 over 1, or 1 over that 3, basically putting it to the negative 1 power, and then we flip the sign. So this negative 3x slope is perpendicular with the 1/3 x slope. Now, things that we haven't gone over, and these are going to be good to just know right away and have these at your disposal. If the problem refers to the x-intercept, that's where the line crosses the x-axis, well, that means the y value is 0, so we'll fill in 0 for y. And if we're referring to the y-intercept, that's where the line, the curve crosses the y-axis, well, that's where the x value is 0, so we'll fill in 0 for x. So we could use this on a problem like number 11. At the point where the line y equals 2c x plus 8 crosses the x-axis, x is equal to negative 4. So negative 4 is the solution. What is the value of c? Now we know that x equals negative 4, but we're looking for when it crosses the x-axis. So we're going to fill in 0 for y. So now we're just going to plug in 0 equals 2. We're going to leave it as c. The problem tells us that x is negative 4 plus 8. So 2 times negative 4, we get 0 equals negative 8c plus 8. Move it to the other side, we get 8c equals 8. Therefore, c equals 1. We have the graphs of y equals 2x and y equals x squared intersect at points AB and CD. What is the value of a plus c? So we need to know what a and c are. And if we look at the ordered pairs, well, a and c are the x points. So we want to know what the x value is of where these two things intersect. And if you quickly can just sketch, the parabola looks like this and the line will pass through, most likely there are 2 points where the solutions are going to be, right? So if they intersect, what we want to do, right, y is equivalent to y, we want to set these equal to each other. So y equals x squared and 2x, right? These are equivalent in this problem. So now we'll solve for x. We'll move this 2x over. So we get x squared minus 2x equals 0. And then we want to factor out. We can factor out an x. So x minus 2. So here, x equals 0. And here, x equals 2 for the solution. So the solution is, or the x values are 0 and 2. So it's 0 comma b and 2 comma d. So if we were adding a and c, we add 0 plus 2 and we get a value of 2. Example that's similar, and it reads, on the xy plane, Ronald creates a scale drawing of a ramp he will build. He knows the slope of the ramp must be a 20% grade. That is, for every 2 feet of vertical rise, the ramp will measure 10 feet in length along the ground. On the drawing, Ronald places one end of the ramp at 4, 5 and the other at p, 8. We want to know what the value of p is. So this is a lot to dissect right away, but we always want to remember, one way of saying slope is rise over run, or you have the change in y over the change in x, Make this a little neater. All right. Now, let's consider this problem, and we could expand this sometimes. We have y2 minus y1 over x2 minus x1, right, using our points. Now, for every 2 feet of vertical rise, so that's going to be our change in y. So if I rewrite change in y over change in x, well, our change in y is 2, and then along the ground, we have 10 feet in length. So the x value, or the run, is going to be 10. So our slope's 2 over 10. Now, on the drawing, Ronald places one end of the ramp at 4, 5, and the other at p, 8. So we want to figure out where exactly this x value is. So we're going to call this point 1 and this point 2. And what we're going to do is we're going to plug it in for here. And remember, the slope equals 2 over 10, right? Our y2 is, let me use a different color. It's going to be 8 minus our y1, which is 5. That's not a 5. Over x2, which is this p, minus x1, which is 4. Now, what I would do, cross multiply, so we get 2p minus 4 equals, what you could do, you could subtract quickly. 8 minus 5 is 3, right? Do parentheses first. 8 minus 5 is 3 times 10. That's going to be 30, right? Cross multiply in this term. So now we're ready to solve for p. So distribute 2p minus 8 equals 30. We'll add 8 to both sides. I jumped the gun, that's 30 plus 8. So we get 2p equals 38. Divide by 2. And we get that p has a value of 19. Okay, so we did exponents way back in February, but it is a key strategy for the test, and we want to look for ways to use those exponent rules. Very, very simple. We want to know our rules cold. We want to have these ready to go at a moment's notice, right? When we're multiplying them together, it's like we're adding them. Dividing, we're subtracting. 1 raised to a power, that's like multiplying exponents. And then remember this, if we have, the square root of x, well, that's like saying x to the 1/2 power. These are equivalent values. So being able to manipulate these exponents is going to help us tremendously. Okay, key strategy number 10. We want to recognize similar triangles. We'll use this whenever we see 2 triangles that are oriented in one of the following ways. So we could have, one triangle embedded in the other with parallel bases, sharing a vertical angle, like the one on the left. Or like I said, with one embedded in the other, we have 2 similar triangle setups. Now the key thing to know is they have proportional sides. So in example 14, the figure above shows an isosceles triangle with the roof, 30-foot triangle roof with a 30-foot base and 15-foot height, and the 10-foot crossbeam to be installed distance x from the base of the roof for support. What is the value of x? Now, what we want to know is, since this is a similar triangle, if we find the height of the smaller triangle, well, this is 15 feet, we can easily find that value of x. But something that may be helpful is to kind of break them apart. So this is 10, that way, that's h. This h is 15, and this is 30 feet. So now we want to set up a proportion. That was the second topic that we studied probably way back in January, and quickly want to set it up. Well, the height we'll put on the left side of the proportion. So 15 over h is equal to the big triangles on top. So that's 30 feet over 10. Quickly, if you want to cross multiply, we get 30h equals 150. Divide by 30. H equals 5. But remember, we don't want to know the height of the small triangle. If this were a multiple choice question, can guarantee that the height or 5 would be a choice. We want to know this value of x. If this is 5, 15 minus 5 is 10. So that value of x is 10. So hopefully these last few strategies are helpful and you can use them moving forward. But thanks for watching, and I hope you got something out of this.